Hello, my name is David Medis, and this is the FOP Fundamentals of Physics class for Javier. And I'm going to be showing you the difference between potential energy and kinetic energy, and also how they interact with different items just around your house. First, I'm going to have a CD, just a plain blank CD, which I tied in the middle, and then tied the other end. Well, I didn't really tie it, but I'm holding on with my fingers. Essentially what I'm going to do is I'm not going to move my left hand, and as I move the CD up and down as it's laying horizontally like this, it's going to create a lot more air resistance when I drop it, which just causes it to, one, spin, and two, not go as high and come back to my hand. But with potential and kinetic energy, you always have to know that the higher you hold an object when you are about to drop it or release it, is the more potential energy you have. And on its way down, the object is basically showing its kinetic energy, how much energy it's applying, basically. So let's say. So with the CD, you can tell that it does not have that much kinetic energy from pretty much wherever I drop it as I'm standing. An object will always, or will never return farther or go farther in the opposite direction from where you drop it. And that will be easily demonstrated further with my next piece that I'm going to choose, which is a hairbrush, just a regular everyday hairbrush. And I tie this onto the bottom, and I'm going to essentially do the same thing. I'm going to hold it tightly with my left hand, not moving it, straighten the string, and then right now we have potential energy moving up and down, greater, less, greater. And as I drop it, we're going to see that it is going to fly in a more straight and also come back to me a little higher pattern. So let's see. Which it did right there. It didn't fully come back to my hand, nor did it reach its opposite point of being up here, but it can't ever go higher because its potential energy starting here is as much as it's going to go. It can never gain more kinetic energy than it initially has. So, and what's causing all this is the air resistance once again. I mean, everything's affected, even to the bristles on the brush, you know, all the way down to the handle, you know, even the string that I'm holding on to. But in, you know, a perfect world, if I was to drop an object from one height, it would not go any higher on the other. If it's attached to a string or something like that, anything. And last but not least, we do have a pen. This is a heavier pen. It's a metal pen, but unlike the other two items, this one is heavier, and we have our potential kinetic, as you all know. So I guess my hypothesis, which is going to be true due to physics, when I drop this, it is going not to go higher, and it will probably become pretty close to my hand. But because it is one of the heavier objects and has less mass, this object, the pen, is easier to flow right through the air, cutting through the air a lot easier than, say, the CD or the cone. So that ought to wrap it up for my potential kinetic and air resistance speech for the podcast in Fundamentals of Physics. My name is David Medis, and thank you for watching.